In this lesson, we're going to learn about the Pythagorean Theorem. First thing we'll look at is a little bit about triangle notation, and then how to substitute into the Pythagorean Theorem. And lastly, we'll look at using the Pythagorean Theorem to find the missing side of a right triangle. So that'll include a little bit of algebra. Now, the Pythagorean Theorem is one method that we use to calculate the unknown side of a right triangle if we know two of the other sides. And you're probably already familiar with it. It would be a squared plus b squared equals c squared. Now, it really doesn't matter which side is a and which side is b. So, for example, in this diagram, we could say that this is side A and this is side A and this is side B. These are interchangeable. However, this third part, c squared, is always the hypotenuse of a right-angled triangle. Now, what this formula is really saying is, remember how the area of a square is length times width, and the length and widths are the same, so it's just length times length, really, or length squared, or just side squared. So b squared is really just the area of a square using this side of the triangle as the length of one of the sides of the square. So b squared would be the area of this square. A squared would be the area of this square, where A is one of the side lengths. A times A would tell us the area of this square. And if we were to add up these two areas, what we're getting is this area of this third square, because C times C would be the area of this square. So c squared is this area. So if you take these two areas and you add them up, you'll get the exact same as this area of this square right here. Now, on these kinds of triangles, often we're used to seeing the vertices labeled. However, we like to. It's easier to see this triangle as having the sides labeled, and this is what I'm talking about with triangle notation. So this is actually triangle ABC, and the way we would know that is if this is lowercase c, this side is length c or side C. This vertex is capital C. It's right across from it. If this is side B, then this vertex would be vertex B, capital B. And if this is side A, then directly across from that would be vertex A. It's always the same letter directly across, and we usually use a capital letter to show the vertex and a lowercase letter to show the side length. Find the length of a side of a square that has an area of 100 centimeters squared. Well, again, we know that the area of a square is equal to its side length squared. And we know the area of this particular square is 100 square centimeters, so we can plug that in for the area. So 100 square centimeters is equal to some side length squared. Now, we don't want to know the side length squared, we just want to know the side length. So how do we get rid of the squared part? Well, the opposite of squaring is square rooting, and whatever you do to one side, you got to do to the other. So squaring and square rooting cancel out, and we're just left with the side length will be equal to, the square root of 100 is 10. Now, as a side note, 10 is only one of two answers. There's actually a second answer. So our side length is 10 because 10 squared is 100. But the side length could actually also be negative 10, because if we take negative 10 and we square it, so negative 10 times negative 10 is also 100. But it doesn't really make sense to have a side length that's negative. How do you have a negative 10 meter length? That doesn't really make sense. So the one that we're going to be using will be the positive, just the positive value. This was just a little bit of a side note. Find the length of the hypotenuse in the given triangle using Pythagorean Theorem. Now for this triangle, you can see that there is no A, B, and C labeled. Instead, there's a 3, a 4, and an H. But you can go ahead and write the A, B, and the C on here. The important one is that C is the hypotenuse. Okay, and then the A and the B, it really doesn't matter which one goes in which spot. I'm going to write A right here, and I'm going to write b right here. So that's just what I happen to pick. You could pick the other way around if you want, as long as c is the hypotenuse. Now we know our equation is a squared plus b squared equals c squared. And according to what I've labeled right here, we can see that a is 3, so 3 squared, plus b is 4, 4 squared equals c squared. But c is h. We don't know what h is. That's what we're trying to figure out. So h squared. Now 3 squared is 3 times 3, that's 9, plus 4 squared, 4 times 4 is 16, equals h squared. H times h is h squared. We can't really simplify that much more yet. Now 9 plus 16 is 25, and that is equal to h squared. What this is really saying is some number times itself, that's what squared means, is equal to 25. So what times itself is equal to 25? You might already know in your head that that would just be 5, but just in case this was some other number that's not a perfect square, we could go the opposite of squaring is square rooting. That will cancel out the squared sign and just leave us with h. But whatever you do to one side, you have to do to the other, and the square root of 25 is 5. So h must be 5. And we can write that right on here. This must be 5 meters. Find the length of the missing side of the given triangle using the Pythagorean theorem in this example as well. Now in this case, the hypotenuse is given, but we don't know one of the side lengths. That's not the hypotenuse. Again, I can just label this A, and this one B, and this one has to be C in our equation, and start by writing down the equation a squared plus b squared equals c squared. Now let's start substituting in our values. A is actually just an x, so x squared plus b is 12. 12 squared equals c, which is 18. 18 squared. Well, x squared is just x squared. We can't simplify that anymore yet. Plus 12 squared is 144 equals 18 squared. I don't know what 18 squared is off the top of my head. If you do, you must be better at math than I am. So I'm just going to pull out the calculator and go, what is 18 times 18? Oops, forgot to click on it. 18 times 18, and we get 324. Now, just using a little bit of algebra, we need to bring the 144 to this side, or cancel it out from this side. So x squared plus 144 minus 144. Okay, so the minus will get rid of the plus. These just cancel each other out, equals 324. Now, since I subtracted 144 from this side, we must also subtract 144 from this side in order to keep the equation balanced. And what we have so far is that x squared equals whatever 324 minus 144 is. And if you're not sure what that is, again, you can pull out your calculator. 324 minus 144, and you get 180. Maybe you'd rather do that in your head. So x squared is 180. And we're almost done. If something squared is 180, again, in the last step, we're going to square root both sides. That will cancel out the squared, and we'll just be left with x. X must be whatever the square root of 180 is, and you probably don't know that off the top of your head, so we'll punch that into our calculator. What is the square root of 180? And we get 13.4. So x must be 13.4, approximately. Now, a good thing that we can do is just think, does that answer make sense? I know you're not going to be doing all this in your head, but just does it make logical sense? Well, we know that this is not the hypotenuse side, so we at least know that our answer should be smaller than this 18. And 13.4 is smaller than 18, because this should be the biggest number out of our three. So yeah, we probably did it right. The lengths of the sides of a triangle are given. Is the triangle a right triangle? Well, what we know about right triangles is that if we take the square of two of the sides and add them together, we should get the square of the hypotenuse. That's just the a squared plus b squared equals c squared. This is always true for right triangles. So is it true for this triangle? Well, we could draw a diagram. So I'm just going to help us visualize it, let's assume for a second it's a right triangle. Maybe it's not. I really don't know yet. And the length of AB is 5, the length of BC is 6.5, and the length of CA is 8.02. So this 8.02 is the longest of the three, so we know that this side must be 8.02. Now the other two are just going to fall into the other two spots, so this can be 6.5, and this side can be 5. Now according to this, CA is 8.2. So that means that this one can be C and this one can be A, or this one is C and this one is A. I'm not really sure yet. Let's check with these other two sides. So the length of BC is 6.5, so BC is 6.5. So this must be the B spot. BC is 6.5 and AB is 5. So it looks like we labeled it all right. Now according to the convention I showed you earlier in the lesson, if this is vertex C, this must be side length C, lowercase c. If this is vertex A, directly across from it should be side length A. So this is side length A. If this is vertex B, directly across from it is side B, lowercase b. But that doesn't really line up with our equation. Okay, so all that really matters is that you know that these two numbers go in the A and B spot, and this number is always the hypotenuse. It's the longest one, and it has to go into this spot. Okay, so don't worry so much about these letters. You should know that if this one squared plus this one squared is this one squared, then the triangle is a right triangle. If that's not true, then it can't be a right triangle. So let's start plugging in these numbers. So I'm saying that 6.5 will go in the A spot, so 6.5 squared plus 5 squared equals the hypotenuse squared, 8.02 squared. Now, it looks like we're kind of done almost, because there's nothing to solve for here. There are no variables left to solve for. But what we're really testing for is it a right triangle or not? Let's figure out what this ends up equaling as one number, figure out what this equals as a number. If they're equal to each other, then this equation holds true and it is a right triangle. If they aren't equal to each other, then the equation doesn't hold true and it can't be a right triangle. So let's see what we get when we go through and figure out what these values are. I can do 5 squared in my head. That's 25. That one's not too bad. I can't really do these other two in my head, so I'm going to pull out the calculator again. So 6.5 squared. 6.5 squared is 42.25. So 42.25. And we also need the 8.02 squared. So 8.02 squared is 64.3204. So 64.3204. Now, are they actually equal to each other? Let's check. Looks like it's going to be close anyway. 42.25 plus 25 ends up equaling 67.25 and 64.3204. Now, is 67.25 actually equal to 64? They're kind of close, but no. They're not equal to each other. So what do we know? We know that a squared plus b squared is not equal to c squared, which automatically means that this is not a right triangle. So no, it is not a right triangle, since a squared plus b squared is not equal to c squared. So in summary, the Pythagorean theorem is used to calculate an unknown side length of a right triangle when the other two side lengths are known. And the formula that we use is a squared plus b squared equals c squared, and that formula holds true for all right triangles. And a and b can be any of the sides as long as c is always the hypotenuse. That's the one rule.